Alright, so we're going to look at third running week's review. Starting off number 1, triangle FUZ is similar to triangle YES. Draw two triangles, label them in the same order as what's shown. FUZ, YES. Alright, label the parts that it tells us. S is 61 degrees, Y is 19 degrees. Alright, it wants us to find angle Z. Z is here, matches up with S. Therefore, angle Z is 61 degrees. Moving on to number 3, we're going to find the sequence of transformations that maps quadrilateral DONL to quadrilateral MIC or MCKY. So this is the first one. This is the second one. All right. First thing that I notice is it goes from quadrant 2 to quadrant 3. And it actually does a turn, but we don't call it turn anymore. We actually use big boy words. And this is a rotation. All right, but we can't just say rotation. We have to say specific rotation. So for this one, if it goes one quadrant this direction, remember if it does not specify which direction, then it will be counterclockwise. So this is counterclockwise, so it is a rotation of 90 degrees. But that was not the only thing that happened to this. It also ends up shrinking. So a shrink is a dilation. Right? But we need to figure out of what scale factor. Scale factor is how much you multiply something by to get from one to another. Right? So dilation with a scale factor. And we need to figure out how can we find that. So the easiest way to do this is either look at a side, which you won't always have straight lines like this one. So it's actually better to look at a point. All right, so on this one, the point that I'm going to pick is D because there's only really one thing that we're going to work with. So D is 6 units away from the middle. All right, it goes to M, which is now only 2 units away from the middle. So if I wanted to take 6 and make it 2, I would divide by 3. But we don't use a division for a scale factor. We have to do a multiple. So the same thing dividing by 3 is the same as multiplying by 1/3. So it is a scale factor of 1/3. So on number 3, your answer is a rotation of 90 degrees and a dilation with a scale factor of 1/3. Moving on, we're going to now look at number 5. We're told quadrilateral GOKU and quadrilateral VETA are similar, with VE is 2x plus 6, KU is 20, TA is 25, GO is 32. Okay, so this is just a similarity problem. Since they said it's similar, we're going to set up a ratio where we're going to put 2x plus 6 over either 25 or 32. I'm going to pick 25. You know, right? Since I did all of them on VETA, I'm going to do it with GOKU next, where I'm going to do 32 because that matches up with the 2x over 20. All right, so at this point we cross multiply. Gives us 20 times 2x plus 6 equals 800. I got 800 by doing 32 times 25. Now, I could distribute that 20. However, if I do that, I'm multiplying 20 twice. The other option is, since I have it left like this, the thing I can do is divide both sides by 20. If I divide both sides by 20, I am left with 2x plus 6 equals 40. Now, to get x by itself, I have to subtract 40 from both sides. When I subtract 40 from both sides, I'm left with 2x equals 34. But don't want 2x, so divide by 2. When I divide by 2, my final answer given is x is 17. Alright, we're going to now move to number 7, where we're told SU is 102, so this entire length here is 102. We're told CO is 64, but 64, TS is 36, and we want OU. Notice, OU is only this part of the side. So, in order to actually do a proportion, we need the matching part. So we need TU. The way that we find that is, whenever I do that, I get 66. Alright, so this part is 66. I set up a proportion. So x can go over two things, either 64 or it can go over 66. I'm going to pick 66. So x over 66 equals 2. Since I start off with the x, I'm going to put 64 over 36. Alright, now it's time to cross multiply. 66 times 64 ends up giving me 4,224. Alright, so 4,224 equals 2. 36 times x, so 36x. Divide both sides by 36. Alright, when I divide by 36, my final answer ends up being 117.33. Alright. That then takes us to our next problem that we're going to look at, which is number 9. On a trip to Paris, Franco visits the Eiffel Tower at 3:57 p.m. The Eiffel Tower is 986 feet tall, so we draw a triangle with that. Franco is 6 feet tall, so we draw a triangle with the height being 6. Okay. It says Franco's shadow is 15 feet long, so I'm going to put a shadow on the ground 15. Okay. We want to know how long the Eiffel Tower shadow is, so we put an X there. Alright, so setting up, same way. X either goes over 986 or X goes over 15. I'm going to pick 15. So X over 15 equals 2. 986 over 6. Cross multiply. Alright, 986 times 15 gives me 14,790 equals to 6 times x, so 6x. Divide by 6. Alright, gives us a final answer of 2,465 feet. Number 10. Travis is playing on base jumping off of a cliff. In order to find the height of the cliff, he stands at the base of a cliff, walks 211 feet from the base, and places a mirror. So here's the base. This would be 211 feet. Here's a mirror. Alright, he then takes 3 more feet backwards and then looks down at the mirror so he can see the height of the cliff. So this is a little demonstration of it. It says if his eye, alright, so it takes a minimum of 100 feet for the parachute to open safely. So he needs to open his parachute 100 feet above the ground. Right? It says his eyes are 5 feet above the ground, so we've got that. How far can he jump down? So we're looking for this distance here. Now, if we actually were doing this, we could do this with an equation. X plus 100 equals to the entire length. But since we only have x in one spot, we can actually instead substitute the entire height for, let's say, y. So if I'm doing this, I'm going to set up a proportion y over 211 equals to, since I did height, it's 5 over 3. Cross multiply. 3y equals to 1055. Divide both sides by 3. So I go into my calculator, 1055 divided by 3 gives us a value of y being 351.66 feet. So we're going to just go ahead and say 352. Now, if Travis was going to jump off this cliff and he jumps 352 feet, he hits the ground. We don't want to do that. We want to have him make sure he can land safely. So we have to actually take the 100 feet from that. All right. When we do that, we get a final answer of 252 feet for the amount of time or distance he can free fall before opening up his parachute. We're now going to look at number 11. So number 11, it says we're going to have A be 41.7 degrees, BC is 66, AC is what we're looking for. Notice we have 2 sides and an angle. Right? So depending on which one we're talking about, it's either going to be a special right triangle or trig. The key on the special right triangles is you either have 45, 30, or 60. This is not one of those ones. So it's going to be trig. So what we have to remember on this one is SOHCAHTOA. So with SOHCAHTOA, we're going to end up looking at this, and we need to figure out which sides we're working with. So first things first, X is across from the right angle, making it the hypotenuse. This part is across from the angle, so that is the opposite. So we have O and H. The only thing that uses O and H is so it's sine. Now again, whenever the SOHCAHTOA, it's a trig function, what's on top, then what's on bottom. So if I'm setting this up, it's going to be sine the angle 41.7 equals to 66 over x. If the variable's on the bottom like this, you switch the positions. Right? So x equals to 66 over sine 41.7. Alright, before you actually plug this in the calculator, we need to make sure our calculator is in degrees. So the way that you do this, you go to mode. Right? When you're in mode, you go down and look for radians and degrees. If it's highlighted degrees, you are good. If it is not highlighted degrees, you need to switch it to it. Right? We go back to the main menu by doing a second mode to quit out. And we just type in 66 divided by sine 41.7. Alright, with this, we get our final answer of 99.2 as our answer. Okay, again, now it depends on which ones we end up having on here. If the variable was on top, we would be multiplying. If the variable is on the left, we would do the inverse. We will see a couple more of these problems that we're going to work through. There is not one where the variable is on top that we're going to actually work through. There might be some on this review that you actually see that way though. Okay, we're going to skip now to number 13. So number 13, we're told AC is 79.3. BC is 69. Alright, we want angle A. So looking at this, first things first, I notice 79.3 is our hypotenuse. 69 is across from the angle, so it's the opposite. So we go back to the SOHCAHTOA, and it is again sine. Okay, so we're going to use sine again. This is now sine x, because it's sine your angle, which is x, equals to 69 over 79.3. Okay, variables on the left. Variables on the left, you do the inverse. So x equals to inverse sine 69 over 79.3. Okay, so the way that we do this, we hit second sine 69 divided by 79.3. Alright, and once we do that, again, notice if you get second sine, you get the little -1 in your calculator, and we end up getting x equals to 60.47, which, if we're rounding to the 10th place like it said, is actually 60.5 degrees. Alright, next problem we're going to look at is number 15. Alright, it says answer in simplest radical form. That should be a hint that it is a special right triangle. So there's two special right triangles, 45, 45, 90, 30, 60, 90. Let's look at this and see which one it actually ends up being. It says R is 45. So 45, 45, 90. It says FR is 25. We want RT, so I'm going to label that with an A because I'm going to be using X's somewhere else. So 45, 45, 90. The trick to that is on a 45, 45, 90, the two legs are the same, so x and x. The hypotenuse is x square root 2. So, setting this up, we're given a leg, 25. Going from leg to hypotenuse, we multiply by the square root of 2. 25 times the square root of 2 is 25 square root 2. You don't really do anything about doing that. That's simplest radical form. Now, the difference on this one is, since it is a multiple choice test, you do have the option of doing trig. If I was to do trig on this, A is our hypotenuse. 25 is next to the angle, so it's adjacent. So this one has A and H, so it is cosine. Cosine, our angle, 45, equals to adjacent, 25 over hypotenuse A. If the variable is on the bottom, you switch. So A equals to 25 divided by cosine 45. And whenever I do this, I type into the calculator 25 divided by cosine 45, and that gives us 35.35. Alright, now notice again, I said multiple choice, you have a little bit of advantage. So you can't, that's not necessarily the same answer as 25 square root 2, but 25 square root 2 would be one of the answer choices. So notice if I type in 25 square root 2, it gives me the exact same value. So whatever we end up doing will give us the same value as doing trig. Now granted, if you remember the special right triangles, you're going to be fine. But if you don't, you have to do the extra. Alright, we're going to skip now down to number 17. So number 17, it tells me that r is 30 degrees. So that tells me straight off the bat, 30 degrees, it's going to be a 30, 60, 90. Right, it tells me also th is 92. It wants me to find tr, so I'm going to label this one as A again. So 30, 60, 90 triangle. Alright, short leg is x, long leg is x, square root 3, and hypotenuse is 2x. So notice on this one, I'm going from short leg to hypotenuse. So x to 2x, that's basically multiplying by 2. 92 times 2, 184. Final answer. Now, say we were trying to find the hypotenuse, or the long leg. If I wanted to find the long leg, I'd have to take that and multiply by the square root of 3. 92 times the square root of 3 would be 92 square root 3. And that would be your answer. But again, we're only looking for TR, and you could also do trig on this one instead, and it will give you the same answer. Now, we're also going to look at number 18, because number 18 is a little tricky because it throws in this square root as something that you're given to begin with. So it tells us that this is 72 square root 3. It wants us to find HR, which is this side here. Right, again, 30, 60, 90, x square root 3, and 2x. It gives us a hypotenuse. Before I can find HR, I need to find the short leg. So 2x to x, we are dividing by 2. 72 divided by 2 is 36, but we did not get rid of the square root of 3, so we leave that there. Alright, then we have to go one step further, and going from x to x square root 3, we multiply by the square root of 3. So if I take 36 square root 3 and multiply by the square root of 3, notice I'm multiplying by 2 square roots of 3's. If you multiply a square root times itself, it's just that number on the inside. So this is actually just 36 times 3. So we go to our calculator, 36 times 3, and our final answer is 108. Alright, so if we were actually trying to find this part, it would be 108, and that is actually what we are trying to find, so we get 108. Alright, we're going to skip numbers 19 and 20, and we're going to move down to number 21. So it says a helicopter pilot spots a landmark at an angle of depression of 20 degrees. The altitude of the helicopter is 1370 feet. To the nearest foot, what is the horizontal distance? So anytime you see angle of depression, we want to draw a triangle in the sky. Right? The angle of depression is going to be with the horizontal line. We put 20 degrees here. All right, altitude is how high the helicopter would be, so that's going to be the one going up and down, 1370. All right, so it wants the horizontal distance. Horizontal distance is just a flat line. So we want the top part. So setting this up, okay, x is next to the 20, but is not the hypotenuse, so that is the adjacent. 1370 is the one across, so it's opposite. Opposite and adjacent takes us to tangent. So we're going to do tan 20 equals to 1370 over x. The variable's on the bottom, so we switch. So x equals to 1370 divided by 1020. We go to our calculator. 1370 divided by 1020, and we get a final answer of 3,764.04, so it's just 3,764 feet because we're rounding to the nearest foot. There's your answer. All right, we're going to skip 22 and 24, or 23, and we're going to move straight to number 24. We've got a yield traffic sign. So if you aren't familiar with this, then it is a equilateral triangle upside down. Equilateral means that all the angles are 60. It says that the width of it is 43 inches. All right, it wants to know the height though. So the height, we're going to draw a line straight through the middle. Make that 90 degrees. We're going to go through there. So notice, we've got a 60, we got a 90. That means that this other one is 30. So we got 30, 60, 90 triangles. Again, on a 30, 60, 90, short leg is x, long leg is x square root 3, and hypotenuse is 2x. But notice that 43 is not the short leg. It is twice the short leg. So we have to divide by 2, giving us that this is actually 21.5. But we need to go from there to the height, so that would be 21.5 square root 3. There's still one extra part to this. It says it wants the answer rounded to the nearest tenth. So 21.5 square root 3 is not rounded to the nearest tenth. So what we do is we plug this in the calculator. And when we plug this in the calculator, we get a final answer of 37.2 inches. And there's your final answer. All right, we are going to now move on to number 26, where it tells us GO is 114, angle O is 35, KU is 81, and we're looking for K. All right, so with this one, we got inscribed angles. So inscribed angles, the rule for this one is it's in. So we're going to take the angle and it equals to the arc divided by 2. All right. So in order to find this angle here at K, we need the arc across from it. All right. To find that arc, we need to find all the other arcs because we know all of them add up to 360. So if we are told that this is 35, from angle to arc, instead of dividing by 2, we are actually going to multiply by 2, giving us this is 70 degrees. Now, when we add up all of these ones, we end up getting 114 plus 70 plus 81. All right. So 114 plus 70 plus 81 ends up giving us 295 or 265. All right, we take 360, subtract 265, leaving us with 95 for this arc. But arc to angle, like we're looking for, we divide by 2. 95 divided by 2 ends up giving us 47.5 degrees as our actual final answer. Okay, we are now going to move on to number 27, which is still more of the same type of problem. It tells me GO is 150, so I put 150 here. OU is 43, put that there. I'm going to find angle O, so I'm going to put an X here. Okay, so we have two of the arcs. We notice O opens up to GU, the entire length here. So if we have the two that don't include that, we can find that easy by adding these two up. 150 plus 43 equals to 193. 360 minus 193 gives you 167. All right, so this entire thing is 167. Arc to angle divide by 2. 167 divided by 2 ends up giving you 83.5. So there's your final answer, 83.5 degrees. Number 29, we have OT is 240. So this entire thing is 240. Now we're going to split that in half. The top part's 120, then the bottom part's 120. Right. It says VA is 64. I'm going to put 64 here. And what's the radius of the circle? So the radius means that from the center of the circle to the outside, we have one line that we can actually use for this, and that would be VO. If I draw that here, I now have a right triangle. I know this side's 120 and I know this is 64. I'm going to draw this on the outside to make it a little bit easier to look at. This is now 120. This is 64. This is X. So, setting this up, Pythagorean theorem. The hypotenuse is the one by itself, so X squared goes by itself, equals to 64 squared plus 120 squared. So, I'm going to type that in the calculator. 64 squared plus 120 squared gives me 18,496 equals to X squared. But I don't want that. I want to square root it because I want the square root of that. 18,496, and that gives us a total of 136 equals to X. So there's your final answer. Moving on, we are now going to look at number 32. So number 32, it tells me angle B is 24 degrees. LW is 108 degrees, and we want to find MU. Alright, so notice, this is one of the ones with the circles. Okay, this time we're looking at angles. So if it's angles, we're looking at in, out, or on. In this case, notice the angle B is outside, so we're doing out. So the rule for out is the angle equals to the big arc minus the little arc divided by 2. Alright, so our angle is 24. Our big arc is 108. Our little arc is X, all divided by 2. To solve for X, we got to multiply by 2. So times 2 on both sides. 48 equals 2. 108 minus X. Subtract 108. 48 minus 108 is negative 60 equals to negative X. Negatives on both sides. Either multiply by -1, divide by -1, or just cross out the negatives to cancel them out, and your final answer is 60 degrees. So again, there's a difference between segments and their angles. Segments is the chord, secant, 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 tangent. Angles is in, out, and on. Speaking of segments, let's look at the next one. Number 33, it says BU is 34. So label that 34. BM is 23. Label that 23. UL is 32. And MW is what we're looking for. So notice this is segments, not angles. So we got either secant, secant, chord, chord, or secant, tangent. If you have part on the inside, part on the outside, that is a secant. So this one is secant, secant. The rule for this is whole times out equals whole times out. So we need to figure out how long the entire line is. So the way that we do this, easy. 34 plus 32, 66. 23 plus X, X plus 23. So the entire length on the top line is 66. The outside is 34. The entire length on the bottom line is X plus 23. I'm going to leave this in parentheses so I don't forget about it. And then the outside is 23, so I put 23 out here. Alright, so I could distribute that 23 like I did like I could have before, but instead of multiplying 23 twice, I'm going to leave it on the outside, and I'm just going to worry about the other side. 66 times 34 gives you 2,244 equals to X plus 23 times the outside, which is 23. Divide both sides by that 23 to get rid of it. So when I divide 2,224 by 44 by 23, I get an answer of 97.56. So since I'm rounding to the nearest tenth, I'm just going to say 97.6 equals to x plus 23. So if I just stop there, I wouldn't be right. So I need to subtract 23. So subtract 23, and I end up getting 74.6 equals to x. So there's your answer. Number 34, we're converting from degrees to radians. So the rule on this one is pi radians equals to 180 degrees. Now, when we are doing any type of conversion, the rule of conversion is you multiply by the new over the old. So if you know a value for the old one and the know value how it relates to the new thing, you can just do this no matter what. This is going like if you're going from feet to inches, centimeters to meters, liters to milliliters. Any of those things works the same way. You just multiply what you have times the new value over the old value. So if I'm going 2 radians, my new is the radians. So I'm going to put pi on top. My old is the degrees, so I'm putting 180 on bottom. I take my original value, 955, multiply by pi over 180. If I do this in terms of pi, which is what I want to do, I do not actually plug pi in the calculator. So this is 955. Since the 180 is on the bottom, I am going to actually be dividing by 180. When I do this, I get a decimal, but I do not want the decimal, so I need to change that to a fraction. The easiest way, hit math, hit enter twice. Notice it has this little to a fraction thing. You hit enter that second time, and it actually converts that to a fraction, leaving you with 191 over 36. Since you did not plug in pi, you need to plug pi back in. It was on top, so we put it back on top. There's your answer. Okay, now we're going to skip 35 and we're going to go to 36, where it's the same thing, but now we're going to degrees. So with this one going to degrees, we put the 180 on top and the pi on bottom. All right, we're going to take the original value. Now I don't like how this is written. You put the pi back on top. So 5 pi over 12 times 180 over pi. So if I'm actually looking at this and I multiply this out, 5 pi times 180 on top. And then 12 times pi on the bottom. Notice we got pi on top, pi on bottom, cancel out. We left with 5 times 180 over 12. That's just what we put in the calculator. 5 times 180 divided by 12. Alright, gives us a final answer of 75 degrees. Moving on, we're now going to look at number 38, where we're told to find the area of circle P. This is circle P. Area formula is pi r squared, so we need the radius. We don't have that. This is the diameter, divide by 2, 105. Area formula, pi times 105 squared. We go to our calculator, 105 squared ends up giving us 11,025. Put the pi back in our answer. Units were feet, so feet squared. We're going to skip 39 and we're going to move to 40, which is similar to number 39. Alright, so for this one, we're looking for the arc length of KGU. So if I'm looking at that, KGU is this entire section here. We're told this is 113. We're told the radius is 14. So we need to use the formula for arc length. Arc length is the circumference times the part over 360. Alright, the part is the measure of the angle, or the arc that we're talking about. So to find this arc, we got to do 360 minus 113, which in this case is 247. So Formula for circumference, 2 pi r. So 2 pi times the radius of this one, which is 14, times the part, which now we know is 247, over 360. Alright, notice it says use the pi button on the calculator. So instead of actually multiplying everything else, we're going to actually type in 2 pi times 14 times 247 divided by 360. And after we hit enter, we get our actual answer, which is 60.35 units per meter, so meters. Alright, moving on to 42. We need to find the equation of the following circle. Formula for equation of a circle is x minus h squared plus y minus k squared equals r squared. Alright, hk is the center of our circle. Alright, r is the radius of the circle. So, we need to figure out where the center of the circle is. You can do that by looking at it. Left 3, up 1, negative 3, positive 1. The radius, you go from the center, count to the outside, and this time we end up counting 5 units. So the radius is 5. Right? All you now have to do is plug into the equation. So x minus a negative 3 is plus 3 squared, plus y minus a 1 is minus 1 squared, equals to the radius squared, which is 5 squared, which is now 25. There is your final answer. So if you're given the radius and the center of the circle, all you have to do is plug in. You have a graph, you can find those very easily. Skipping to number 44, this one's a little trickier because it does not give you the radius. You instead are given a point and the center. But we can do the same thing. So I'm going to leave the equation at the top so you can look at that real fast. But h and k, h is 8, k is 7, and we're going to replace this time x with 13 and y with 15. Okay. The reason why we're doing this is we're going to plug those in to solve for r squared, and then take those back out and replace r squared. So this would be 13 minus 8 squared plus 15 minus 7 squared equals r squared. 13 minus 8 is 5. 15 minus 7 is 8 equals r squared. 5 squared is 25. 8 squared is 64 equals r squared. 25 plus 64 is 89. Alright, so now we have an r squared. All we have to do is take the x and y back out, and we've got x minus 8 squared plus y minus 7 squared equals 89. There is your final answer. Alright, we're now moving to the very last question, number 46. Okay, it gives us an equation. We have to graph it. So, in order to graph this, we need the center. Right? We look at the equation. Remember, it's the opposite of whatever we have there. So, it becomes positive 3, positive 2. The radius is the square root of what's on the right. So, the square root of 36 is 6. So, we're going to graph the original one. Right? We go to 3, 2. So, right 3, up 2, put a dot. Since the radius is 6, we count from that dot up 6, put a dot. Count from that dot left 6, put a dot. Count from that dot right 6, put a dot. Count from it down 6, and we put a dot. Those 4 dots we're going to connect with what's best looking like a circle as possible. Remember, in multiple choice, you can pick which one is actually the right spot. Right? So, you're looking mainly on multiple choice at the radius as well as the center. You get those right and you're good. Alright, so this was the entire review. Best of luck. The questions I did not cover are ones that you can still do. It's just for more practice.